Hey everyone, and welcome back to your math class. Today we are entering lesson 17, which is some practice problems with two variables. So without further ado, let's get into the plan for the day. All right, so we're going to start this class with a brief review of the steps that are required to solve a problem with two variables, and then we're going to do some practice problems. Now, I was kind of umming and erring about adding some word problems to this lesson as well, and I was kind of thinking, last lesson we were kind of easing our way back in after Semana Santa, and I was thinking, it went a little bit long. It was about 40 minutes. There's a chance that you guys didn't get into your math class as early as you normally do, and maybe it didn't last as long as usual because it was the first day back. So as a result, I kind of got this feeling that maybe you guys didn't quite finish that lesson fully. So I've decided to leave the word problems out for today. We're going to just do two practice problems because one of them ended up being a little bit more difficult than the ones that we've seen so far through most of this unit. So we're going to leave the word problems for next week. So that'll be in Tuesday's class. We'll do the word problems. And then next Thursday, so a week after you guys watch this video, we're going to do a test review and you guys will have time to study for the test. And then the test itself will be the Tuesday after that, which, if I've done my math right, should be April 16th. So I'm going to have more information about the test, what's going to be on it, when the review sessions are going to be, how many review sessions there are going to be. I'm going to do all of that as soon as I can. My schedule is a little bit up in the air for the next few days. And by next few days, I kind of mean a couple of weeks. But so I'm going to figure out exactly what's happening with my schedule, and then that'll tell me what blocks of time I'm free in to do the review sessions. And I'll keep you guys posted. It'll be somewhere either in our next video lesson, or I'll make a special video that's just a couple of minutes long to announce that information so that you guys have access to it. And yeah, if you guys have any questions, I know I haven't checked the YouTube channel at all in the last couple of days, so if there have been questions, I'll get to them very soon. But yeah, if you guys have questions about anything we've covered so far or anything from today's video, let me know and I will absolutely help you with whatever you're struggling with. So with that, let's get into today's lesson. So here we go. We're going to review the steps that are required to solve problems with two variables. Now, we did look at this exact text last class, but there's a lot going on here. It's a 6-step solution, it's a 6-step plan to solve problems with two variables. And there's a lot of colors going on. There's a lot of equation 1, equation 2, variable 1, variable 2 stuff going on. So I want us to take another look at the plan, because it's one of those things that, if you don't know the plan very well, then you're going to freeze when it comes time to do the test, because maybe you can kind of follow along while we do the problems in class, but then it comes test day, you're a little bit stressed, you studied, but maybe you didn't have enough time for it, or you're not quite as prepared as you'd like to be. And then because you're stressed, you're not thinking clearly, and then you're going to mix up, you're going to kind of envision this PowerPoint slide in your head, and you're going to see the colors. You're going to see that there's red and green and blue and purple, and you're not going to remember exactly what's going on. So I want to make sure we understand what's going on in the plan in terms of the logic, in terms of understanding why we're doing what we're doing. And then we're going to dive into two practice questions today. The first one is harder than the second one. And hopefully that'll get you guys more prepared. Now I'm also going to see if in time for our next class, if I can prepare a few sort of homework questions for you to do between Tuesday and Thursday, and then I can kind of go through the answers on Thursday. But one step at a time. So we'll see if I can do something like that in time for Tuesday's lesson. But anyway, so steps to solve problems with two variables. First things first, you got to label your equations. So that's just a matter of making it easy for you to talk about what's going on in the problem in an organized way. So that's the whole point of step one, is that you could call them equation one and equation two. Maybe you don't like that. There's enough numbers in the problem. You don't want to add more numbers to it. You could do equation A and B. You know, if you've got an easy way that makes sense to you and that you think would make sense to me of identifying your equations, it could be the left equation and the right equation. I don't really mind how you label your equations as long as it's clear to me or to whoever's marking your test what it is that you're doing, right? What, you know, equations you're working with, what variables you're working with, and why you're doing what you're doing. So in order for you to explain why you're doing what you're doing, we need to make sure we all understand it first. So you label your equations, equation one, equation two. Then you're going to isolate one of the variables in one of the equations. So suppose you've got your variables are x and y. Now I want to be clear. I'm going to just pretend, just because it's a little bit less wordy to say one of the variables and then the other variable or the second variable, I'm going to pretend that the first variable I'm isolating is x. That's not a very pretty x, but you know what I'm trying to do. And I'm going to say that the second variable is y. Now, when you're doing these kinds of problems, if it's easier to isolate y first, you totally can. If it's not x and y, if it's a and b, if it's w and z, you can isolate whatever you want. You don't have to go in alphabetical order. If you see an x, that doesn't matter. You don't have to do x first. If it's p's and q's, pick whatever you want. Do p first, do q first, doesn't matter. Whatever's easier for you when it comes to isolating the variables. So I'm just going to say, just because it's a little bit less wordy, I'm going to say x and y. So suppose you isolate x in equation one, just because equation one is green and this one here is green. So suppose you isolate x in equation one. What that allows you to do is it allows you to write x in terms of y. And I've used that phrase a few times. I'm not sure if I actually properly explained what it means to write one thing in terms of another. So to write x in terms of y means that you're able to say what x is by using y's and numbers in your expression, in your way of describing x. You can talk about it by talking about y's. So what does that mean? So suppose you want to talk about how much an apple costs. Just hypothetically, let's talk about like fruits, right? So you want to talk about how much an apple costs, and you don't know exactly how much an apple costs. You know, you're given some amount of money and you don't really pay attention to how much money it is by like an older sibling or something, and they say, go buy me an apple. Sure. So you go and you buy them an apple, and for some reason you have no idea how much money your older brother gave you, so you have no idea how much money you paid for the apple, but you know that it was enough for you to buy an apple. And then the next day he gives you some amount of money. He tells you it's the same amount of money as the previous day, and he says, go and buy me 3 oranges. So now you go and you buy 3 oranges. And if it's the same amount of money, and for some reason you don't know how much money that was, you know that 1 apple costs the same thing as 3 oranges. So you're able to talk about how much an apple costs by talking about oranges. You know what I mean? So you're able to describe one number, one quantity, without talking about that quantity itself. So that thing gets hidden, and then you end up talking about something else that achieves the same goal, that is the same description. So I hope that makes sense. That might not be the clearest explanation, but I'm recording this late at night, so please bear with me. Yeah, so the idea behind this step 2 is that you want to isolate one of the variables so that you don't have to talk about that variable anymore, because anytime you want to talk about x, you know how to write it down using y and some numbers and some operations, so like addition, subtraction, multiplication, division, anything but x, right? Because the reason for that is that when you get to step 3, whichever equation you didn't use to isolate, so suppose we isolate x in equation 1, we're going to now go over to equation 2, and we're going to rewrite it using only y's wherever we see x's. And what that does is it turns it into a 1 variable equation, which is something that we know how to solve because we already talked about how to solve algebra problems with one variable. So isolating x in one of the equations allows you to write the other equation as a one variable problem with this other variable, with y. And that lets you solve for y. Now, once you've solved for y, it's not a variable anymore. You know the value of y, so you can go back to the equation that you started with, and you take that value that you got for y, suppose y equals 1, and you rewrite that first equation, but you plug in y equals 1. And then that'll allow you to solve for x, because now you've turned the first equation into a one variable problem. So there's a lot of moving parts there, and I keep going back to this. I keep wanting to re-explain the steps of how to solve these problems, because just in my past experience, I explained the steps once, maybe twice in a very similar way. And everybody's like, yeah, I understand. And then it comes test day and everybody freezes and nobody knows what to do. And that's my fault for not explaining it enough times or in enough different ways. So that's why I keep coming back to this, and I hope that makes sense. And now we're going to test this out with two practice problems. Now, what I'm going to do is I'm going to go through these two practice problems in full, like I'm going to go through the full solutions, but because they're practice problems and not examples, what I would like you all to try first is to pause the video and try and work on the problem. The first problem might take you several minutes, might take you 7, 8, 10 minutes to figure out exactly what's going on, exactly what the easiest way to solve the question is, just because there's a few bigger numbers in there and you might have to do some long multiplication or something like that. But that's how you're going to test whether you understand these steps. So make sure you have these steps written down somewhere. If you've never written them down before, pause right now and write these steps down, because when I go to the next slide, I want you to use these steps to figure out how to solve the problem. So we're going to try that and see how it works. And then if I get a whole bunch of comments saying I don't understand what's going on, then I know I need to fix something. So let's take a look at the first practice problem. So practice problem 1, we're only doing two practice problems today. The first one is find the values of A and B given the following. So you've been given two equations. Both of them have some information about A and some information about B. So we've got A and B shows up in both of them. And we need to figure out what A and B are. So what I would like you to do here is pause the video, go back to the text on the previous slide. If you've written it down, just flip your notebook to that page. And I want you to try and work through this question. You guys can all try it independently if you're feeling confident enough. If you're not, you can try to solve it together. I'm not against you guys working together to try and understand how to solve the problem. The only thing I don't want is that like two of you understand it better than everybody else, and the two of you solve it and you talk about it, and then you kind of leave everybody else behind and you press play. I don't want that. I want to make sure that everybody's on the same page, everybody's understanding what's going on. And if you guys try that, then that'll be a really good way of knowing where exactly you all are and, where are we getting stuck, what's not making sense. And then you can come back here and look at the solution. So I'll give you a few seconds to pause the video and to take a stab at the question, and then we'll look at the answer. All right, so now let's take a look at the solution. So the way I'm going to go through the solution is I'm actually going to write out the steps and then I'm going to perform that step. So step number 1, label the equations. Cool. So I'm going to pull out my red pen and I'm just going to put a 1 right there. So that's equation 1. And I'm going to put a 2 over there. So that's equation 2. So I'd like to label them with 1 and 2 and put circles around them so that I can see that they're not like part of the question, right? Because if I didn't put the circle, then if I wrote this a little bit closer, it looks like a 13 because the 1's too close. And over here, maybe it looks like 402. So give it a little bit of distance, put them in circles or squares or like with a highlighter, whatever works for you. But that's step 1, label the equations. 1 and 2, A and B, doesn't matter. Step 2, I'm choosing to isolate the variable a in equation 2. Now you don't have to do this. Technically, you could isolate a in equation 1. You could isolate a in equation 2. You could isolate b in equation 1. Sorry about the sound, that's the fridge. And you could isolate b in equation 2. All four of those are equally valid, correct options. Like there's no wrong choice of which variable to isolate. The only thing is some of them are harder than others. Some of them are more difficult to isolate than others. So for instance, I could very easily say, oh, b by itself over here in equation 2 makes it a good candidate to isolate because all I have to do is subtract 2a from both sides and I'll end up with b equals 40 divided by 2a, right? So if I just write that down, if I were to isolate b in equation 2, that would give me b equals 40 minus 2a. Did I say divided by before? I meant subtraction. 40 minus 2a. That's what I would get if I were isolating for b in equation 2, right? Just subtracting 2a from both sides. Here's why I'm not choosing to do that. I'm a little scared of doing all the multiplication and then all the isolating that's going to come later, because if I say b is equal to 40 minus 2a, when I plug that into equation 1, I have to take this guy, this 40 minus 2a, and I have to multiply it by 14, right? Because it's 14b over here in equation 1. And I don't want to do that. I don't want to do that big multiplication and then do all this other work with it, with the, isolating a and then figuring out what a is. We're starting to deal with really big numbers, right? With 40 times 14, and then there's a 29 in there, and there's going to be a 14 times 2 in there. It's just going to be a big mess. So because I am looking ahead at that, I don't want to isolate b. Even though it looks easier, I don't want to isolate b. So instead, I'm going to isolate a. And my reasoning for that is, sure, oops, I shouldn't have erased that last bit. My reasoning for isolating a is that if I isolate a in equation 2, it's not being multiplied by a huge number over in equation 1. It's only being multiplied by 3. So that's easier math to do in my head. It's easier to check that I got the right answer. So that's why I'm going to isolate a in equation 2. If I do that, I get a is equal to 40 minus b, all divided by 2. So how do I get that? That's by first subtracting b from both sides. So we get 2a is equal to 40 minus b. And then you divide both sides by 2. So you divide this by 2, and then the 2's disappear, and then you divide that side by 2, and that's how you get a is equal to 40 minus b, all divided by 2, which is this expression right here. Step 3, we're going to take that result. So we now know how to write a using b and a bunch of numbers. We know how to, so we've got like a 40, we've got a 2, we've got subtraction, we've got division, and we've got b. But we don't have any a's there. So we can rewrite a in terms of stuff that isn't a. And what that lets us do is it turns it into a one variable problem. The only variable that shows up, even though it's a little bit messy here, the only variable that shows up is b. So we don't actually have too much work to do to solve the problem anymore. We've got to kind of sort out what's going on with these brackets over here. But other than that, it's not too bad. So what I've done here is I've just taken that last expression that we got at the end of the previous slide, and I've put it right here so that we can kind of see what we started with when we start solving for b. So step 4 is solve for b. So we've taken equation 1, and wherever we see an a, so just in this one spot right here where we have an a, we've substituted in this expression right here, 40 minus b divided by 2, which we got from the other equation. So we're dealing now with equation 1, because this basically looks like equation 1, just a looks a little bit different. So we solve for b in equation 1. So first things first, a little bit of distributive property stuff, which hopefully you guys have seen before, but in case you haven't. So basically what I want to do is I want to take this 3 over 1, basically, and I want to multiply it by this fraction over here, this 40 minus b divided by 2. So when I do that, I'm going to write it up here. So that's 3 over 1, because that's the same thing as 3, times 40 minus b all divided by 2. Now we know how to multiply fractions. We multiply the numerators together, we multiply the denominators together. Denominators are easy. That's 1 and 2. 1 times 2 is 2. Cool. Numerator, we have to do that distributive property thing. So if I put this thing in brackets, it looks like something we've seen in the last lesson or two, where we have a number on the outside that we want to multiply by a bunch of things on the inside. So the way the distributive property works is if you've got these two things on the inside, the 40 and the b, we're going to take the guy on the outside, the 3, and we're going to multiply it by each of those two things individually. So 3 times 40 is 120. 3 times b is 3b. Nothing too complicated there. And this minus sign that we have right here, we just keep the minus sign right there. If we had a minus sign on the outside, then we'd have to flip all the signs on the inside. Minus would become plus and plus would become minus. But because we don't have that, we just carry over exactly the same sign as what was in the brackets. So that's how we get this thing right here. 120 minus 3b divided by 2. That's this guy up here. Cool. And then this minus 14b just comes straight down. I didn't do anything else besides this stuff up here. That's all I've done in this first step, is I've figured out what's going on with the big thing in brackets. Now we're going to take another step. And what I've done here is I've gotten a common denominator. So how did I get a common denominator? Well, I've got a denominator of 2 on this side, and technically I've got a denominator of 1 on that side. So I've multiplied my numerator and my denominator by 2, right? If I've done this by 2, then I have to multiply the numerator by 2. So 14b becomes 28b, so that's this guy right here. The denominator becomes 2, and then we can mesh the denominators together, because that's what happens when we add and subtract fractions. And we're doing subtraction because we got a minus sign here, so we have a minus sign here. So you can see there's a lot kind of going on in this problem. That's why I wanted us to really take our time with it. But now we're starting to get somewhere, because now we can see that we've got minus 3b, right? We've got like some number, whatever, minus 3b minus 28b. So if we mash those two bits together, negative 3 minus 28, that's negative 31. So we've got 120 minus 31b, the whole thing divided by 2, equals 29. So once again, I've run out of slide space, so we're going to go on to the next slide, and I'm going to copy this guy over to the next slide. So that's this right here. So we've got 120 minus 31b all divided by 2 is equal to 29. Now we're continuing with solving for b. So here my first step is going to be, I'm going to multiply both sides of the equal sign by 2. And that's going to get rid of the denominator of 2 on the left side, so those just vanish. And on the right side, we end up with this 29 times 2 guy, which is equal to 58. So this is what we get. We get 120 minus 31b, and there's no denominator anymore because that's what we got rid of, equals 58. And so now I don't really like that there's a minus sign here, so I'm going to add 31b to both sides. That'll get rid of the 31b on the left side. There's going to be a plus 31b on the right side. And then I'm going to get rid of the 58. I'm going to subtract 58 from both sides. So I'm going to do this in one step. You can do it in 2 steps if you'd like. But what I'm doing is I'm adding 31b to both sides. And then I'm subtracting 58 from both sides. And what that gets me is this expression right here. So 120 minus 58 equals 31b. and we can figure out what 120 minus 58 is. That's 62. And then now all we have to do is divide both sides by 31, and we get that b is equal to 2. So all of that work to find out that b is equal to 2. Cool. Now, so we did all of this work basically with equation 1, right? Let's, if we rewind the tapes a little bit, we started out by isolating a in equation 2. That's this guy over here, right? Then we took that expression, we plugged it into this equation over here, equation 1. Then all of our work we did with equation 1. We figured out what b is using equation 1. So now we're going to take that answer for b equals 2, and we're going to go back over to the other equation, and we're going to plug that result into the other equation. So instead of 2a plus b, we're going to say 2a plus 2, because b is equal to 2. And all of a sudden, this is a one variable problem as well. And so we get that 2a plus 2 equals 40. So now there's just one a by itself, like it's got some like multiplication and addition, but there's no other variables. So it's a one variable problem. We know how to solve that. So we just have to isolate a, and that's what you get. So first we subtract 2 from both sides. We get 2a equals 38. And then you divide both sides by 2, and you get a equals 19. So there you go. We've got that b is equal to 2 and a is equal to 19. And you can always check your work that you've done this right by plugging 19s wherever you see a's up here. So we plug a 19 there, and that's going to be multiplication. And then plug a 19 over there as well in equation 2. And then in place of the b, we'll put a 2. And then we'll check that we get left side equals right side in both cases. So 3 times 19 is 57, minus 14 times 2 is 28. So 57 minus 28. 57 minus 28, that's like 57 minus 30 plus 2. It's 27 plus 2. So it's going to come out to 29 equals 29. On the other side, in equation 2, we've got 2 times 19, which is 38, plus 2 equals 40. So we get 40 equals 40. So we can be confident that we've solved this question correctly. All right, here is practice problem number 2, which is, I think, easier than practice problem number 1. So the only thing to watch out for here is we've got quite a few minus signs going on all over the place. So just be careful with your minus signs, and when you're doing like multiplication and subtraction and stuff, try not to lose your minus signs, because that's sort of like the number one mistake that math students like to make in algebra, is they lose a minus sign somewhere and they get an answer of +2 instead of -2 or something. So just try and keep track of your minus signs. I'll give you a few seconds to pause the video, and then I will solve the problem. All right, so now let's take a look at the solution to practice problem number 2. So step number 1, label the equations. So I'm going to grab my pen, and I'm going to say this guy over here is equation 1, and this guy over here is equation 2. There we go. Now I've decided that I'm going to isolate Q in equation 2, basically because it looks like the easiest, right? It's sitting there by itself. So I'm going to isolate Q in equation 2 by adding 2p to both sides. You can see we've gone away from x's and y's, right? Because I don't want you to think that you have to go for the x first or the thing that's first alphabetically or anything. We got p's and q's. P comes before q in the alphabet. My name starts with a p, but I'm still choosing to isolate the q, right? So whatever is easiest for the math, that's all that matters. So isolating q in equation 2, we now know that q is equal to 2p minus 2. So q is the same thing as 2p minus 2. So what that lets us do is it lets us rewrite equation 1, but anywhere that we see a q, we know that that's equal to, we know that that's the same thing as 2p minus 2. So wherever we see a q, we're going to write 2p minus 2. So equation 1 looks like this: 12p minus 8q. The q becomes 2p minus 2, so we have to stick that whole thing in brackets, equals 0. Cool. Now we have to solve for p. So here is where the distributive property looks a little bit weird, and I'm going to explain what I've done there. So I'm treating this minus sign, even though it looks like we're doing like a subtraction, I like to treat that minus sign as part of the number that's out in front of the brackets. So I like to treat this as -8 times 2p minus 2. And if I do that, then when I do the distributive property, I'm going to take -8 and I'm going to multiply it by 2p. So -8 times 2 is -16. And then -8 times -2 is going to be positive 16. Oh, and this is -8 times, sorry, in the first step, it's -8 times 2p, so I got to add the p in. And then in the second step, it's -8 times -2. That's positive 16, so that's why we're going to put a plus sign here and a 16. So that's -16p plus 16. That is this piece right here. So basically we just ignored the 12p. We pretended that this 12p didn't exist, and then we did the rest of the problem, and you get -16p plus 16 from this multiplication problem with the brackets over here, and that's the result that you get. It's a one variable problem. We can take this 12p minus 16p, that's -4p plus 16. So you see where the minus signs, I just didn't want you to get lost with the minus signs. Don't lose that minus sign, because otherwise you'll get a different answer. But yeah, so -4p equals, -4p plus 16 equals 0. I don't like having the negative there, so I'm going to add 4p to both sides, which gives me 16 equals 4p, which tells me that p is equal to 4, because if you divide both sides by 4, then that's what you'll get. 16 divided by 4 is 4. So cool, now we know what p is equal to. So first we isolated q in the second variable, or in the second equation, sorry. Isolated q. Then we went over to equation 1 and we figured out what p is equal to. P is equal to 4. Now I'm going to take that answer, p is equal to 4. I'm going to go back to equation 2, and wherever I see a p, I'm going to put the number 4. I'm going to put in 2 times 4 in that spot right there. So this becomes a one variable problem in equation 2. And so that's what we get here. Equation 2 becomes q minus 2p becomes q minus 2 times 4 equals -2. And it's a one variable problem, so we just solve for q. And we get that 2 times 4 is 8, so we have an 8 there. Q minus 8 equals -2. Again, lots of minus signs floating around. Try not to lose them, otherwise you'll get the wrong answer. And you'll get that q is equal to 6, because if you add 8 to both sides, you'll get that q is equal to 6. And so then once again, you can check your work by plugging p equals 4 and q equals 6 into both equations, and then checking that you get the left side is equal to the right side. You don't have to do that, but when it comes to the test, if you have the time to do this kind of a step to check your work, you will automatically know that you got the right answer without waiting for me to mark it, or without waiting for your other teachers to mark it. So it's really cool that you have that little kind of hack that you can figure out if you got the right answer. Like if the entire test was these kinds of algebra problems and you did this check at the end of the question to see if you get left side equals right side in these equations up here, you would know automatically what mark you got on the test. That's how powerful this checking tool is. So if you have the time on the test to do this check and you find that you're not getting left side equals right side, you've made a mistake. You either made a mistake when you were checking, or you made a mistake in the solution, and that gives you a chance to go back and find the error. So let's do the check, but that's why I wanted to show it to you guys, because that's the importance of it. So if we go ahead and do this check, 12 times 4, 12, 24, 36, 48, minus 8 times 6. 8 times 6, you should just know it, but 8 times 6 is also 48. So we get 48 minus 48 is 0. So 0 equals 0. Cool. That's a good sign already, just that it works out with one of the equations. But we'll double check with the other one as well. Q is equal to 6. Don't have to change anything there. 2 times 4 is 8. 6 minus 8 is negative 2. Negative 2 equals negative 2. So because we got that left side equals right side for both equations, when we plugged in the numbers that we found for P and Q, we can be confident, actually we can be certain, but we can be confident that we did this problem right. And that is all for this lesson. Now, I know it's also taken like 36 minutes to get through this lesson, which is pretty similar to how long most of our lessons usually are. But I hope this makes sense, and I hope you see why I abandoned the word problem, because I wanted to spend a lot of time going through the solutions to the practice questions. But yeah, hopefully that all made sense. If you have any questions at all, please don't hesitate to let me know, and I will be more than happy to help you out. But if there are no questions, then I will see you all next week for the next lesson. Have a good one.